Hey everyone, welcome back to the channel. Ever looked up at the night sky and wondered about those twinkling lights? The night sky is a vast expanse filled with countless stars, planets and other celestial bodies. But did you know that not all those twinkling lights are stars? Some of them are stars, but some are satellites. These man-made objects orbit our planet, serving various purposes that are crucial to our daily lives. Satellites are like mini spacecraft orbiting our Earth. They come in different shapes and sizes, each designed for specific tasks. From the moment they are launched into space, they begin their journey around our planet, tirelessly working to gather and transmit data. They do all sorts of amazing things. Some satellites are designed to monitor the Earth's environment, while others are used for communication, navigation, and scientific research. Each type of satellite plays a unique role in enhancing our understanding of the universe and improving our quality of life. Some take pictures of our planet, helping us understand weather patterns and climate change. These Earth observation satellites provide critical data that scientists use to study natural disasters, track deforestation, and monitor the health of our oceans and atmosphere. Others beam TV signals and internet connections all over the globe. Communication satellites make it possible for us to watch live broadcasts, make phone calls, and access the internet from virtually anywhere on Earth. They bridge the gap between remote areas and urban centers, ensuring that information flows seamlessly across the globe. Satellites are essential for navigation, communication, and scientific discovery. GPS satellites, for example, help us find our way whether we're driving in a city or hiking in the wilderness. They provide precise location data that is crucial for everything from military operations to everyday navigation apps on our smartphones. They are like our eyes and ears in space, constantly observing and reporting back to Earth. These satellites collect and transmit vast amounts of data, enabling scientists to make groundbreaking discoveries and helping us stay connected with the world around us. Let's learn more about these incredible feats of engineering. Satellites are marvels of modern technology, designed and built by teams of dedicated engineers and scientists. They represent the pinnacle of human ingenuity and our relentless pursuit of knowledge. So next time you look up at the night sky, remember that some of those twinkling lights are our very own creations, working tirelessly to make our lives better. Think of a satellite like a school bus. The payload is like the students riding inside. It's the specific job the satellite is designed to do. This could be taking pictures, transmitting signals, or conducting experiments. The bus, on the other hand, is like the bus itself. It's everything that supports the payload and keeps it running. This includes the structure, power system, communication systems, and even the propulsion system that helps the satellite move. Just like a bus needs a good engine and strong wheels, a satellite needs a robust bus to function properly. Building a satellite is like constructing a spaceship in miniature. The mechanical structure is the backbone of the satellite. It holds everything together and protects the delicate instruments inside. This structure needs to be incredibly strong to withstand the intense vibrations during launch. But it also needs to be lightweight to make it easier and cheaper to send into space. Engineers use special materials like aluminum alloys and carbon fiber, which are both strong and light. They often design the structure with a honeycomb pattern, which provides extra strength without adding too much weight. Every satellite has a brain, the onboard computer. This computer controls all the functions of the satellite, from collecting data to adjusting its position. But space is a harsh environment, and the computer needs protection from harmful radiation. Cosmic rays and charged particles can damage electronic components, causing them to malfunction. To prevent this, engineers use something called radiation hardening. This involves using special materials and design techniques to make the computer more resistant to radiation. It's like giving the computer a suit of armor. Section 5. Powering up in Space Electrical Systems. In this chapter we will explore the fascinating world of how satellites generate and manage their power while orbiting Earth. Just like any other machine, a satellite needs power to operate. Without a reliable source of energy, the satellite's instruments and communication systems would fail, rendering it useless. But there are no power outlets in space. Unlike on Earth, where we can simply plug into an electrical socket, satellites must find alternative ways to generate the power they need. So, how do they get the energy they need? The answer lies in harnessing the abundant energy of the sun, which is always shining in space. The answer is solar power. Solar energy is the most efficient and reliable source of power for satellites. By using solar panels, Satellites can convert sunlight directly into electricity. Satellites have large solar panels that convert sunlight into electricity. These panels are designed to capture as much sunlight as possible, even as the satellite moves through its orbit. These panels are like giant wings that soak up the sun's energy. They are made of photovoltaic cells which are specially designed to convert light into electrical power. But what happens when the satellite is in Earth's shadow? During these periods, the satellite cannot receive direct sunlight and must rely on stored energy. That's where batteries come in. Satellites are equipped with high-capacity batteries that store excess energy generated by the solar panels. The solar panels charge the batteries, which then provide power during periods of darkness. This ensures that the satellite remains operational even when it is not in direct sunlight. It's a clever system for harnessing the power of the sun. By combining solar panels and batteries, satellites can maintain a continuous supply of energy, allowing them to perform their vital functions without interruption. This intricate balance of energy generation and storage is a testament to human ingenuity and the advanced technology that makes space exploration possible. From powering scientific instruments to enabling communication with Earth, the electrical systems of satellites are a marvel of modern engineering. So, the next time you use your GPS or watch satellite TV, remember the incredible journey of energy that makes it all possible. The sun's rays, captured by solar panels, stored in batteries, and converted into the power that keeps our world connected. In conclusion, the electrical systems of satellites are a crucial component of their operation. By leveraging solar power and advanced battery technology, satellites can function efficiently and reliably, ensuring that we stay connected and informed no matter where we are on Earth. Section 6. Staying on target. Attitude control. Imagine trying to take a picture of a specific spot on Earth while riding a roller coaster. That's the challenge satellites face. They need to maintain a precise orientation in space to point their instruments in the right direction. This is where the attitude control system comes in. It uses sensors like gyroscopes and star trackers to determine the satellite's position. Then, it uses small thrusters or reaction wheels to adjust the satellite's orientation, keeping it perfectly aligned. Section 7. Zooming through space propulsion systems. Satellites don't just stay in one place, they need to move around to reach their designated orbits or avoid space debris. That's where propulsion systems come in. These systems use various methods to generate thrust, which is like the force that pushes the satellite forward. Some satellites use chemical rockets, while others use electric propulsion systems, which are more efficient for long-duration missions. Choosing the right propulsion system depends on the satellite's mission and how much it needs to move around. Section 8. Talking to Earth communication systems. Satellites are constantly collecting data and sending it back to Earth. They also receive commands from ground stations telling them what to do next. But how do they communicate across such vast distances? The answer is radio waves. Satellites have communication systems that use antennas to send and receive radio signals. These signals carry information just like radio waves here on Earth. Ground stations are like giant listening posts that pick up these signals and relay the information to scientists and engineers. It's an incredible feat of long-distance communication. Section 9. Keeping cool, thermal control. Space is a place of extreme temperatures. The environment in space is vastly different from what we experience on Earth. In direct sunlight, it can get incredibly hot, reaching temperatures of up to 250 degrees Fahrenheit or 120 degrees Celsius. While in shadow, it can be freezing cold, plummeting to minus 250 degrees Fahrenheit or minus 160 degrees Celsius. These temperature swings can damage sensitive equipment if not properly managed. The delicate instruments on board a satellite are designed to operate within a specific temperature range. That's why satellites have thermal control systems. These systems are crucial for the satellite's functionality and longevity. These systems use a combination of passive and active methods to regulate the temperature inside the satellite. Passive methods are those that do not require any power to function. Passive methods might involve using special insulation materials or coatings that reflect heat. These materials help to maintain a stable temperature by minimizing the amount of heat absorbed or lost. Active methods might involve using heaters or louvers that can be opened and closed to control heat flow. Heaters can be turned on to warm up the satellite when it gets too cold, and louvers can be adjusted to either retain or release heat as needed. It's like having a thermostat for the entire satellite. Engineers on the ground can monitor and adjust these systems to ensure the satellite remains within its optimal temperature range. This careful management is essential for the satellite to perform its mission successfully. Over the years, thermal control systems have evolved significantly. Early satellites had very basic thermal control mechanisms, but modern satellites are equipped with advanced systems that can handle the extreme conditions of space more effectively. Designing these systems requires a deep understanding of thermodynamics and material science. Engineers use computer models to simulate the thermal environment of space and test different designs to find the most effective solutions. Once a satellite is launched into space, its thermal control system becomes one of the most critical components for its operation. Without proper thermal management, the satellite's mission could be compromised. Thanks to these sophisticated thermal control systems, satellites can operate in the harsh environment of space, collecting and transmitting valuable data back to Earth. This data is used for a variety of applications, from weather forecasting to communication and navigation. The success of a satellite mission is a testament to the ingenuity and hard work of the engineers who design and build these incredible machines. Thermal control is just one of the many challenges they overcome to make space exploration possible. And that concludes our section on thermal control. Keeping cool in space is no small feat, but with the right technology, it's entirely possible. If this video helpful, don't forget to give it a thumbs up, subscribe to the channel, and hit that notification bell. Thanks for watching.